Good day, everyone. I am Michaela Versosa, and today we are going to tackle about mid-latitude cyclones. As you can see here in the image, it shows swirling clouds that visually depict how a mid-latitude cyclone looks from a satellite or aerial perspective. The swirling motion represents the large-scale rotation of air due to the low-pressure system characteristic of mid-latitude cyclones. Okay, so what are mid-latitude cyclones? These are large, low-pressure weather systems, and they are typically found between 30° and 60° latitude, and they are associated with strong winds and fronts, and they travel from east to west. So basically, mid-latitude cyclones are large-scale, low-pressure systems that form between 30 degrees and 60 degrees latitude in both hemispheres. They are caused by the interaction between warm tropical air and cold polar air. These systems are responsible for much of the stormy weather, strong winds, and precipitation in temperate regions, making them vital to understanding weather patterns across North America, Europe, and some parts of Asia. Okay, so next we have the formation of mid-latitude cyclones, where they begin along the polar front where cold polar air meets warm tropical air. A disturbance in the atmosphere, often caused by waves in the jet stream, initiates a rotational movement. Okay, so as the cyclone develops, the warm air rises over the cold air, leading to cloud formation and precipitation. This process is known as cyclogenesis, which continues until the system reaches maturity. Okay, so this image shows the interaction between warm and cold air masses at the polar front, where the mid-latitude cyclone forms. The arrows as the image depict the direction in which the warm and cold air move, leading to the rotation of the cyclone. Next is the life cycle of mid-latitude cyclone. A mid-latitude cyclone goes through four key stages in its life cycle. First is the cyclogenesis, second mature stage, occlusion, and precipitation. First is the cyclogenesis, where formation of it is the formation of the cyclone. Okay, so in the mature stage, the system has a well-defined cold and warm front, producing heavy rain and strong winds, while during the occlusion, the cold front catches up with the warm front, lifting the warm air and weakening the cyclone. Eventually, the system dissipates as temperature differences diminish, which is the dissipation. Okay, so this image highlights the various stages of the cyclone's life cycle, showing the positions of the warm and cold fronts at each phase. The arrows illustrate the airflow, while cloud symbols represents areas of precipitation. Okay, next we have a structure of a mid-latitude cyclone. The structure of a mid-latitude cyclone consists of distinct warm and cold front. The warm front is where warm air gradually rises over cooler air, leading to widespread cloud cover and light rain. And cold front, however, forces warm air upward more rapidly, creating thunderstorm and heavier precipitation. And the occluded front forms when the cold front overtakes the warm front, lifting the warm air completely off the ground and signaling the cyclone's weakening. And next, we have weather associated with mid-latitude cyclones. In the precipitation, we have rain, snow, or thunderstorm, while in the wind patterns, we have strong winds near the fronts. In the temperature fluctuations, we have warm air ahead of the warm front, followed by cold air behind the cold front. Basically, mid-latitude cyclones are responsible for a variety of weather conditions, including rain, snow, thunderstorms, and clear skies, depending on which part of the system you are located. Ahead of the warm front, expect light rain and warmer temperatures, and near the cold front, conditions are stormier with heavier rainfall or snow, followed by a significant drop in temperature. This image illustrates different weather conditions associated with each part of the cyclone. For example, areas in the front of the warm front shows light rain, while the cold front brings intense thunderstorm and showers. The arrows indicate wind directions and the color gradients may represent temperature changes, helping visualize how weather conditions shift around the cyclone. Let's proceed to the importance of mid-latitude cyclone. Mid-latitude cyclones play a crucial role in redistributing heat and moisture around the globe. They transport warm air from the tropics toward the poles and cold air from the poles toward the equator. Okay, so this movement helps moderate the Earth's overall temperature, making the planet more habitable. These cyclones also bring essential rainfall to many regions, supporting agriculture and water supplies. Next, we have mid-latitude cyclones versus tropical cyclones. While both mid-latitude and tropical cyclones are low-pressure systems, they differ significantly. First, mid-latitude cyclones form in temperate regions, while tropical cyclones is in tropical regions. Second, mid-latitude cyclones are driven by temperate contrast, while the tropical cyclones are by warm water. Third is mid-latitude cyclones involve fronts, while tropical cyclones do not. So, in conclusion, mid-latitude cyclones are essential for understanding weather. Their development and behavior help predict severe storms, and they are crucial for balancing heat and moisture in the atmosphere. And that's all. Thank you so much.